Hello, algebra students. I thought I might as well make a video of the rest of the test review problems that are not done in the other video. Some of these we did in class, but this is something you can refer to if you want to. So let's look at them. So the ones that are already done in blue are uh, in the other video. So we're just looking at the ones that have not been done yet. So let's look at number 4. So this is division. So we subtract exponents. And first we deal with the numbers. We have a -4 in the numerator, and the denominator, there's no number, but there is a negative sign. So we could think of that as -1. But at any rate, negative divided by a negative is positive. So our answer is positive, and there's nothing, the 4 is not divided or multiplied by any other number. So we just have 4. It still is still there. Now look at the variables, and we have m to the second power in the numerator, and in the denominator just m to the first, right? There is a 1 there that's understood. So the first power, so subtract the exponents. 2 minus 1 is 1, so we have m to the first power in the denominator. And we don't have to write the 1, of course. So the p squared, look at the p. Well, it's 2 in the numerator, it's also 2 in the denominator, so 2 minus 2 is 0. So we would have p to the 0. And you could think of that as you could write down p to the 0, but what does 0 mean? As an exponent, it means it's not multiplied any, right? The exponent is how many times you're multiplying that. And this time it's not multiplied any, so we just don't write it down. And we also know p to the 0 is 1, right? So it's just 1, and you don't have to write 1. So that takes care of the p's. We might notice, does it make sense for that? Sure. It makes sense to not write any p down because we have p squared and p squared. They cancel. We can see right there you're not going to have any p's, right? Okay. So that leaves the q, and there is a q in the denominator, and that's the only q we have anywhere, so it just stays there. So that is the answer to that one. Now I've snuck in another problem just to show you something. Let's look at this one. We didn't talk much about exponents, the reasons for these rules of subtracting exponents. So let's look back first of all, before we go on to number 4.5. Look at number 4 and look at those m's. We said we subtracted exponents, but let's just focus in on the m and nothing else. We could write it up here. M squared is in the numerator, but that means m times m, right? It means write it twice. Okay, so there we have it, m times m, because the exponent is 2, and in the denominator the exponent is 1, so we only write it once. And well, notice this cancels. That 1 in the denominator cancels one of those in the numerator. You might say it subtracts away from the numerator. The numerator was 2. The exponent, that is, was 2. There were 2 m's. But there's 1 in the denominator that cancels one of those. So that's 2 minus 1, and it leaves just 1 m. And that's what we have in our answer, right, was an exponent of 1. So that's why you subtract. You're really just canceling. Okay? So let's look at the 4.5. Looking at the numbers, we have 8 over 16, and that actually simplifies, right? That's a fraction, and we can reduce that, divide both of those by 8. So 8 divided by 8 is 1, 16 divided by 8 is 2. And we've reduced that. And now let's look at that x squared and x to the 5th. We would subtract exponents, and we would get x to the negative 3. And we say, okay, we don't use negative exponents. Our answer is supposed to only have positive exponents. So we move it to the denominator and make it positive. So we get rid of x to the minus 3 in the numerator, and we make it x to the positive 3 in the denominator. Okay. That 1 looks kind of funny sitting there. We'll move it over to the middle. And that's our answer. But we could also save a little time. Notice we took 2 minus 5 and got negative 3 as the exponent for the x, right? We had x to the negative 3 in the numerator, and then we moved it to the denominator and made it positive. But we could have just said, well, 5 minus 2 is positive 3, and the numerator is a smaller exponent, right? The denominator has the larger exponent. So we take 5 minus 2 and get 3, and it stays in the denominator. Okay, so that's where it ended up happening, right? So you can look at those and just see, well, which one's bigger? And that's where your variable and exponent will be after you subtract the bigger minus the smaller, and you just leave it as a positive exponent. Okay, so if we, again, took the exponent in the numerator minus the exponent in the denominator, then in a case like this, where the denominator had the larger exponent, we would get the negative exponent and switch it to the denominator anyway and get the same thing. But, you know, the alternate way is a little faster. Just say 5 minus 2 is 3. The 5 was in the denominator, so the 3 is in the denominator as the exponent and base. Okay. So we did number 5. Oh, and let's go look at one more thing. Let's look at those x's just like we looked at the m's. We would say, okay, x squared is in the numerator, and in the denominator you have x to the 5th, so that means multiplying 5 times. And some of those are going to cancel, right? You have that canceling and that canceling. So you have 3 left, okay, just like we have here. So that's why you could subtract, say, well, there's 5 of them in the denominator, 2 in the numerator, which that will cancel away 2 of them from the denominator. So 5 minus 2 leaves 3. Okay, and so we have x to the 3rd in the denominator. So we did number 5 already. Number 6 is subtraction. We know the minus sign distributes. So we do have, looking at the larger exponent first, we have a negative 2 to the x, 2 times x to the 4th there. And that's we subtract 6 x to the 4th from that. So it's negative 2 minus 6. So that's negative 8, right? So just writing this down, negative 8 x to the 4th. And that takes care of that one and that one. And then we have x cubed is our next largest exponent. That's 3. We have 5x cubed, and then we have minus negative 5x cubed. This minus must, of course, distribute, so we're subtracting a negative 5x cubed, which means we're adding 5x cubed. So 5x cubed plus 5x cubed, that's 10x cubed. And we can cross those out. Now we have 4x squared minus 2x squared. Again, this minus sign distributes. And so 4x squared minus 2x squared is 2x squared. And hopefully that's one of the answers, and it is. That is A. Okay, go ahead and cross those off as well. 7 we had already done. 8 is find the product. So this is just, we FOIL this, which is just applying the distributive property twice. So the 7k has to be times each of those. 7k times 5k is 35k squared. 7k times 4 is 28k. Then we take the negative 2 times 5k, which is negative 10k, and we take the negative 2 times 4, which is negative 8. Now we combine like terms. 35k squared, well, there's no other k squared, so that's it. And then we have 28k and minus 10k, so that it leaves plus 18k. And then we have minus 8. Okay, so let's look at the next two. We did number 11. Number 10 I think we did in class, but some of you have been quarantined or not been in class, so let's look at number 10. This was the easier one, right? In the other video, I do number 11, and you can see it on this video worked out. And we'll also post these notes of all these worked out. But in this video, we'll look at number 10. So this is the easier one to factor. We want to find numbers that multiply to, let's see, I'll draw a line here to separate these out. Multiply to 27. No, wait, I've left off a step. We don't know what we want to multiply to yet because we have not set this to 0. Well, let's do that first. We're going to add 5 to both sides, right? B squared plus 12b, and then add 5 to both sides, so that's 32 equals 0. So now we know our numbers need to multiply to make 32 and add to make our middle term, which is 12. Okay, with a little bit of thought, we say, okay, 4 and 8 will work. So that's our numbers, 4 and 8. And this is an easy one to factor because once we find those numbers, we don't have to split the middle term. We don't have to do any of that. You can actually do it that way, but you don't have to, because when the coefficient of this first term, the squared variable, is 1, like it is in this case, when it's not some other number, once you find those numbers, you just make a binomial like this, and put the b there, and then write the numbers right there, plus 4 and plus 8, and it's done. Okay, we just took those numbers and plopped them in there. And so we do have it factored. We wanted to solve it by factoring, so we've rewritten it in factored form, and of course it was equal to 0, so we have it set to 0. Now to solve it, we say one of those two factors has to be 0 for the product of them to be 0. So we say b plus 4 equals 0, or b plus 8 equals 0. For the first one, we solve that, subtract 4 from both sides. B equals negative 4, and then we have or b equals negative 8 when we solve that one for 0 by subtracting 8 from both sides. So we do have that as one of our answers. B up here shows that as the solution set, negative 4 and negative 8. And so that's it. Okay, so the next one, next set of problems, write each polynomial in standard form and then name each polynomial by degree and number of terms. Okay, first one's easy to put in standard form. It's already in standard form. There's only one term. Okay, so let's name that. Well, that is, the degree is 5, so it's quintic. And it just has one term, so it's a monomial. So a quintic monomial. Okay, let's look at the next one. It's not in standard form. We have to rearrange that one, number 14. The term with the larger exponent is the negative 10k to the cubed. So write it first and then plus 1. So that's in standard form. And that one is the degree is 3. So it's a cubic. There's a 2 terms, so it's a binomial. So cubic binomial. Okay. So end behavior, we've already done 15. We will now do 16. So I have this little chart over here. And with the telling the end behavior for each of the 4 possibilities, and sign in each of these cases, sign means the sign of that first term when you put it in standard form. That is that term that has the largest exponent. What is its sign? Okay, and that's what's important. So we're looking at that term that has the largest exponent. Okay, so let's look at this one. So the sign of that first term is positive, and the degree is odd. So sign positive, degree odd. It's this one right here. So that end behavior is negative infinity, to positive infinity. Okay. Okay, so let's look at, and let's see, I guess, so yeah, we sometimes put positive here. I wasn't doing that over here in the chart. You really don't have to. It's understood that it's positive. Okay. So let's look at the other page. Page 2. Have a few more of these to look at. So we did number 17 in the other video. And number 18 we did in the other video, and number 19 we did in the other video. Actually, we did all of these, I guess. This entire second page we already did. So you can watch that other video to review those. So that is all. I hope this helps, and see you later.